Alright, so what we're going to talk about this week are reflections. Um, Reflections is something that you probably, a concept that you probably already saw sometime in your middle school days. And so we're going to go ahead and touch up on them. What we know about reflections are isometrical. Okay, that's isometry. That means that reflections are equidistant or equidistant, and reflections are also congruent. Okay, so apologize for the disgusting handwriting, but I'm working with a stylus. I'm hoping maybe I'd probably go get a new one soon. But for now, this is what we do. So reflections are equidistant and they're congruent. What that means is this: if I have this triangle right here, and I am trying to reflect it across this blue line. Okay, so here's my blue line, and I'm trying to reflect that triangle across the blue line. My triangle, okay, will be somewhere like this. Now, let's pretend that my beautiful triangles look the same. And so what we need to know is that they're equal distance from each other. That means that however far away I was from this blue line to that triangle is the same as this blue line to this triangle. That also means that these two triangles are congruent. They're exact same shape. Okay, if this were to measure 3 inches, this is also 3 inches. If this line down here measures 5 inches, then this also measures 5 inches. Okay, so that is what we have to know about reflections. All right, so let's talk about some problems that you're going to encounter. All right, problem number 1. They give you a triangle, and you need to reflect it over your y-axis. Okay, for those of you who are confused or don't remember, hopefully maybe you've been partying too much during spring break, understand that this is your y-axis. Okay, and let me go ahead and pick another color in blue. This would be your x-axis. Okay, I hope we still remember this. This is x, and this is y. So, we need to reflect it over the y-axis. Well, you're thinking, well, that's super easy. Of course it is. So we're going to go ahead and just, if this was 1, that goes there. Here, I'm going to count how many spaces I went from here to here. And so there's 1, 2, 3, 4, 5, 6. So I'm going to go ahead and go over here and count to 6. And it'd be somewhere there. And then this one also went 6. Or 1, 2, 3, 4, 5, 6. So I'm also going to go 6 this way. And there is my triangle. And that is my reflection. Now, here's your trick. Your trick to reflection. Anytime that they're going to ask you to reflect over your y-axis, the x will change. The x will change. So here's what I mean. Suppose they give you a coordinate plane of x, y, and they want you to reflect it over the x. It is going to turn into this. Negative x over y. Notice how my x was positive over here, and we went ahead and changed it to a negative. So if your x is positive, you change to a negative. If it was negative, you would change to a positive. So here's how this would work. Let's look at our coordinates that I put in here. My coordinates here, let me use, I don't know what I picked, orange. Okay, so if I reflected, my reflection point over here should be, my x will change. So if it was negative 7, it'll turn into a positive 7. My y stays the same, so I'm going to go ahead and keep a 7 down here. Over here, I'm going to go ahead and say that negative 7 turns into a positive 7. That 3 just comes down. This negative 2 will turn into a positive 2, and my 3 just stays the same. Okay, now I want to go ahead and check these points with my image, and I'm going to say that I possibly failed because I used the wrong points. Let me go ahead and erase that. That's because these were, the graph threw me off a bit here. So I used the wrong points, but here we go. I should have a point at 7, 7. So here's 7, and here is 7. So there's my point. I was off by 1. It should have been 7, 3, which is right here, and it should have been 2, 3. 2, 3 right here. Now, this is my triangle. Let's pretend that looks nice and fancy.